Hi, in this video we're going to write the following vectors in component form. So we've got here magnitude directional form. So we've got vector A is 4, 30 and vector B is 6, 300. So A is equal to 4, 30. That's r, theta. So r is the magnitude, so that's the length of the vector, and theta is the direction. So, and it's important that we try to draw a diagram to visualize the problem. So drawing a set of axes, and we know this is I, this is J direction. So we want, remember the angle starts from here and goes round anti-clockwise this way. So it starts here, so an angle 30 will be about here, and want the line to be about a length of 4. We're going to just draw a rough diagram. And then the components of this vector will be from this length from here, and this length to here. So the x component is OX, and in this case the y component is XY. So using some trigonometry, cos 30 is OX over 4, cos of 30 is OX over 4, which will give the OX, which is the x component of the vector, is 4 cos 30. This is called the x component, so the x component is given by r cos theta, and the y component, we need to know that sine 30 is xy over 4, sine of 30 is xy over 4, therefore xy is equal to 4 sine 30, therefore the y component is r sine theta. Vector A will be the x component, which is 4 cos 30i, which is this length here, 4 cos 30, plus the y component, which is 4 sine 30. Now cos of 30 is root 3 over 2. The general form then of a vector in component form, if you've got it in this format, any vector v will be r cos theta will give you the x component, I, plus r sine, that's the y component of j. And that's what you need to remember. Theta being the angle measured anti-clockwise from the x-axis going round in an anti-clockwise direction. So that's going to be, now cos 30 is root 3 over 2, 2's into 4 go 2, so it's 2 root 3i, plus sine 30 is a half of 4 is 2, so it's 2j. Now other ways of writing it, now we can also write vector as column in a column matrix, 2 root 3, 2. This is the x component, this is the y component. Or if we use the numerical values of these two values, of 2 root 3 is 3.46, 2, or in that format 3.46i plus 2j. So just be aware of there's many different formats here. Okay, these are exact answers, these are numerical answers. Okay, let's have a look at the second one. Vector B is 6, 300. That's r cos theta. Again, draw a diagram. So, 300 is going to be all the way around in the what's known as the fourth quadrant, and my line needs to be 6 along. Again, it's just a rough diagram. If this is 300, this angle here is 60. So this length is 6. This is my right angle triangle. This is the x component, which will be positive. This is the this is the I component, which will be positive, and this will be the j component, which is negative. So using b is equal to r cos theta I plus r sine theta I. That's going to be r is 6 cos 300i plus 6 sine 300j. Now this will give the same as 6 cos 60, which is what this is, but this one, if you want it, you have to remember that it's negative 6 sine 60j. Okay, so it might be better just to use this, because this will give the answer out straight away. So cos of 60 is root 3 over 2. Root 3 over 2, cos of 60 is a half, I beg your pardon. Cos 60 is a half of 6 is 3, so it's 3i, and sine 60 is root 3 over 2, so root 3 over 2 times 6 is 3 root 3j, but it's minus. Okay, if you do this directly, this will give a minus answer. or if you're going to write it in column vector form, that's going to be 3 minus 3 root 3. We're using the numerical values 3i plus 5.20j minus 3 root 3, or as a column vector 3 5.20. So these are the things that this is writing a magnitude direction form into what's component form. Okay, quite important to draw a diagram in both cases. Now you can think about this using a bit of trigonometry: first, second, third, fourth. So any vector here in the first quadrant is going to be positive, positive. Any vector in the second quadrant is going to be negative, positive, negative x component, a positive y component. In the third quadrant it would be a negative I component, negative j component, and here positive I, negative j. Okay, so I hope you've understood this, and I thank you very much for watching.